Greetings to Madam Manisa. My name is Li Chunxian, and today I have a presentation of heuristic construction. First, we need to know what is heuristic. A heuristic is a practical problem-solving strategy that employs creative and computational thinking to devise efficient solutions for non-routine mathematical problems, which often require innovative approaches due to their complexity. Unlike traditional algorithms, heuristics promote adaptability, encouraging individuals to explore diverse methods, break down problems into simpler components, recognize patterns, and focus on key elements, thereby fostering critical thinking and innovative solutions in varied mathematics scenarios. In this presentation, we have three levels of difficulty of questions, which is first one, easy, and the second one, intermediate, and third one, also last one, advanced. First, we look at the easy question. A boy wants to get stronger. He decides to do more push-ups each day. On the first day, he does 1 push-up. On the second day, he does 3 push-ups. On the third day, he does 5 push-ups. He keeps going like this. Analyze how many push-ups does he do the 10th day. We can see here the keyword analyze. So the Bloom's taxonomy having used is C4, analyzing. Now let's look at how to solve the problems. First, we break the problem into smaller parts to understand it. Day 1, the boy do 1 push-up, day 2, 3 push-up, and day 3, 5 push-ups. Then we determine the pattern in the numbers. Then we use the pattern to find the number of push-ups on the 10th day. After we do the composition, we look for a pattern in the numbers. We list down the numbers 1, 3, and 5. From 1 to 3, it increased by 2. From 3 to 5, it increased by 2 again. So the pattern is increased by 2. The numbers are odd numbers, and each day adds 2 more push-ups than the day before. Now we find the answer using different heuristic strategies. The first heuristic strategy we use is look for a pattern. The numbers are day 1, 1, which is 2 times 1 minus 1 equal to 1. Day 2, 3, which is 2 times 2 minus 1 equal to 3. Day 3, 5, which is 2 times 3 minus 1 equal to 5. We can notice that the pattern is 2 times the day and minus 1. So for day 10, we use the rule. 2 times 10 days minus 1 equal to 20 minus 1 equal to 19 push-ups. So the conclusion or the answer is, on the 10th day, the boy will do 19 push-ups. Now we look at the second heuristic strategy that we use in these easy problems, which is make a table. We make a table to list the days and the number of push-ups. We start with the days we know. We can see day 1, 1 push-up, day 2, 3 push-ups, day 3, 5 push-ups. Each day, the number of push-ups increased by 2 compared to the day before. So we add 2 to the previous day's number to find the next day's push-ups. For example, for day 4, 5 plus 2 equal to 7. Day 5, 7 plus 2 equal to 9. And we do this until day 10. 17 plus 2 equal to 19. So compare the first heuristic strategy, which is find a pattern. We also get a same answer. On the 10th day, the boy will do 19 push-ups. Now we look at the computational thinking concepts that used in these easy problem solutions. The first one is decomposition. We break the problem into steps to find the 10th day push-ups. And the second one, pattern recognition. We spot the pattern of odd numbers in those push-ups. And the third one, algorithm design. Make a plan to use the pattern and calculate the answer.
Now we look at the question of intermediate level. At the school picnic, kids are making a treasure hunt in a small park shaped like rectangle that's 12 meters long and 6 meters wide. They want to split the park into 3 equal zones for hiding treasure, using string to mark the zones. They want to use the least amount of string so they can finish quickly and hunt for treasure. Evaluate which way is the best to split the park into 3 equal zones and how much string will they need. We can see there is a keyword evaluate, so the Bloom's taxonomy that used in this question is C5, evaluate.
To solve this question, first we need to break it down. First, we need to draw the park and find a way to make 3 equal zones for hiding treasure. Then, we count the string needed and pick the way that uses the least. This is decomposition. And step 2, we draw the park. Step 3, we think about the important parts. The area equal to 12 times 6 equal to 72 square meters. And we need to split it into 3 equal zones. So each zone has 24 square meters. Then step 4, we try different ways to split it into 3 equal zones, each 24 square meters. In step 4, we have 2 ways to split the park into 3 equal zones. The first way is split it into 3 tall strips. We cut the 12-meter side into 3 parts, 4 meters each, because 12 divided by 3 equal to 4, and each zone is 4 meters times 6 meters. 4 times 6 equal to 24 square meters, so it's right. And the string needed is 2 strings to split into 3 zones, each 6 meters long, and the total string is 2 times 6 equals to 12 meters. For way 2, we split into 3 long strips. We cut the 6 meter side into 3 parts, 2 meters each, because 6 divided by 3 is equal to 2, and each zone is 12 meters times 2 meters. 12 times 2 is equal to 24, so it's right. And the string needed is 2 strings to split into 3 zones, each 12 meters long. They go side to side. Total string 2 times 12 equals to 24 meters. In heuristic strategy 1, draw a diagram. And step 5, we need to pick the best way. And it is evaluation in computational thinking skills. For way 1, we got 12 meters long string. And way 2, we got 24 meters long strings. 12 meters is less than 24 meters, so way 1 is better. In conclusion, the kids should split the park into 3 store strips, each measuring 4 meters by 6 meters, and they will need to use 12 meters of string to mark the zones. Now we look at the other heuristic strategy that we can use in this intermediate question, which is experiment with options. So step 1, we need to find the area of the park. The area of the park is 72 square meters, and we need to split it into 3 equal zones, so each zone is 24 square meters. For step 2, we need to experiment with splitting the length. First, we try to splitting the 12 meters length into 3 parts. 12 divided by 3 equal to 4 meters. So each zone is 4 meters by 6 meters. It's 24 meters square. So it's correct. This need 2 strings across the Y's, which 6 meters each. So the length of string is 2 times 6 equals to 12 meters. And the second, we try splitting the 6 meters wide into 3 parts. 6 divided by 3 is 2 meters. Each zone is 12 meters by 2 meters. 12 times 2 is equal to 24. And it's correct. So we need two strings across the length, 12 meters each. And length of string is 2 times 12 equal to 24 meters. For step 5 in experiments with options, we need to choose the length string. From the even split along the length is 12 meters and split along the width is 24 meters of strings. So we need to choose splitting along the length, which is 12 meters. So the kids should split along the length into 3 zones, each 4 meters by 6 meters, using two strings of 6 meters at 4 meters and 8 meters. And they will need to use total 12 meters of string to mark the zones. Now we look at the computational thinking concept that we use in intermediate question. The first one, decomposition. We break the problem into steps to find the zones and the string needed. And the second one, abstraction. We focus on the parts area and string length, ignoring other details. And the third one, evaluation. We compare string lengths to choose the best way to split the part.
Now we look at the question of advanced level. At a school fun fair, Leo is running a lemonade stand to raise money for new playground equipment. He starts with a big jug of lemonade measured in cups. Each hour, he sells some cups of lemonade and then adds a few cups to his jug to keep it ready for the next hour. After 3 hours, Leo has 10 cups of lemonade left in his jug. Here's what he does each hour. He sells half of his lemonade and then he adds some cups, the same number of cups each hour. Leo knows he added either 4 cups or 5 cups each hour, but he can't remember which.
A. How many cups of lemonade did Leo start with and how many cups did he have after each hour? Find all possible answers.
B. Leo remembers that after the first hour, he had at least 13 cups of lemonade. Based on this, did Leo add 4 cups or 5 cups each hour? How many cups did he start with? The Bloom's taxonomy that used in this question is C5 evaluate and C6 creating.
Now, let's look at the solution for question A. Step 1. We break the problem into smaller parts to understand it. It is decomposition. First, we need to know Leo has 10 cups of lemonade after 3 hours. And second, each hour he sells half his lemonade, then adds either 4 cups or 5 cups. Then we need to find how many cups he started with and how many he had after each hour. Since Leo adds either 4 cups or 5 cups, we'll try both possibilities by working backwards. And step 2, we work backwards for possibility 1 and possibility 2. Possibility 1, Leo adds 4 cups each hour. And possibility 2, Leo adds 5 cups each hour. Now we look at the solution for possibility 1, which is Leo adds 4 cups each hour. We need to know, after hour 3, Leo has 10 cups. He added 4 cups at the end of hour 3, so before adding, he had 10 minus 4 equal to 6 cups. If he adds 6 cups after selling half, then before selling, he had doubled that number. 6 times 2 equal to 12 cups. So, at the start of hour 3, he had 12 cups. After hour 2, Leo has 12 cups. Before adding 4 cups at the end of hour 2, he had 8 cups. Before selling half, he had doubled that number. So is 16 cups. So, at the start of hour 2, he had 16 cups. After hour 1, Leo has 16 cups. Before adding 4 cups at the end of hour 1, he had 12 cups. Before selling half, he had to double that. So is 24 cups. So at the start of hour 1, he had 24 cups. Now we look at the solution of possibility 2. Leo adds 5 cups each hour. As we do in possibility 1, we start at 10 cups. For our 3, he sells half, so 10 divided by 2 equal to 5 cups. And 5 plus 5 equal to 10 cups. So after our 2, he has 10 cups. For our 2, we do the same solution. So we can get after our 1, it also 10 cups. For our 1, we do same solution. And we can get Leo start with 10 cups of lemonade. Now we look at the last step and also step 3 for question A, heuristic strategy 1, working backwards, is list all possible answers. If he added 4 cups each hour, he started with 24 cups. After hour 1, 16 cups. After hour 2, 12 cups. After hour 3, 10 cups. And if he added 5 cups each hour, he started with 10 cups. After hour 1, 10 cups. After hour 2, also 10 cups. After hour 3, 10 cups also. Now we look at the second solution for question A, trial and error. For step 1, we set up the problem. Leo starts with S cups. It's an unknown or a variable. Each hour, he sells half of his lemonade and adds A cups. A is either 4 or 5. After 3 hours, he has 10 cups. So we need to find S and the cups after each hour for 2 possibilities. For step 2, we start to do trial and error. For possibility 1, Leo adds 4 cups each hour. Possibility 2, Leo adds 5 cups each hour. Now, we do trial and error for possibility 1. Leo adds 4 cups each hour and A equal to 4. We all know, after 3 hours, he has 10 cups and Leo starts with S cups. So, we assume for trial 1, we assume that S equal to 16. We take 16 divided by 2 and plus 4 and we can get 12. Then we take 12 divided by 2 plus 4 and we get 10 for our 2. For our 3, we take 10 divided by 2 and plus 4 equal to 9. 9 is too low for 10, so we need more cups. Try a higher S. For trial 2, we assume that S equal to 20 and we use the same way as trial 1. We can get after our 3 is 9.5 cups of lemonade. 9.5 is also too low for 10, so we need more cups and we need to try a higher S. For trial 3, we try S equal to 24 and after solution we get, after our 3 we get 10 cups of lemonade. This works. For A equal to 4, starts with 24 cups, then 16, 12 and 10 cups. Now we do the trial and error for possibility 2. Leo adds 5 cups each hour and A equals to 5. We know that after 3 hours, he had 10 cups and Leo starts with S cups. For trial 1, we try to assume the S equal to 8. Then we do the same way as possibility 1. We can get after our 3, Leo has 9.75 cups and 9.75 is too low for 10 and so we need to try a higher S. For trial 2, maybe we can try S equal to 10. After we do that, we got it. After our 3, we got 10 cups. This means we are correct. For A equals to 5, starts with 10 cups, then 10, 10, 10 cups. For step 3, we need to answer the question. Although we already get the answer, but we need to write it in sentence. The answer is, if Leo adds 4 cups each hour, he starts with 24 cups of lemonade and after the first hour, he has 16 cups. After the second hour, he has 12 cups and after the third hour, he has 10 cups. If Leo adds 5 cups each hour, he starts with 10 cups of lemonade. And after the first hour, he has 10 cups. After the second hour, he has 10 cups. And after the third hour, he has 10 cups also. Now, we look at the solution for question B. In question B, the heuristic strategy that we use is guess and check. We know that after hour 1, Leo had at least 13 cups of lemonade. So, we can do guess and check. Possibility 1, which is at 4 cups. After 1 hour, Leo has 16 cups. 16 cups are more than 13 cups, so this works. For possibility 2, which is at 5 cups. After hour 1, Leo has 10 cups. 10 cups are less than 13 cups, so this doesn't work. So, Leo must have added 4 cups each hour, and he started with 24 cups. Then, we look at the computational thinking concept in the question of advance. The first one is decomposition. We break the problem into steps to find the starting cups. The second one is abstractions. We focus on the lemonade amount and ignore other details. And the third one is logical thinking. We use reasoning to compare results and choose the right option.
Hi, I am the AI avatar and I will present the part of conclusion. The heuristic presentation highlights how computational thinking skills and heuristics can elevate teaching quality, reshape education, and cultivate innovative thinkers. It employs computational thinking concepts such as decomposition and pattern recognition, paired with heuristic strategies like creating tables, identifying patterns, and exploring options through experimentation to illustrate a structured approach to problem solving. These skills empower teachers to simplify complex concepts, fostering critical thinking and creativity in students through hands-on, unplugged activities. By driving education towards innovation, this method nurtures students' curiosity and resilience, key traits for future inventors. The presentation also aligns with the course's big idea: mathematics as a universal language for empowering teachers with computational thinking skills, demonstrating how mathematics enables teachers to address challenges systematically and inspire a global student community. Additionally, this approach bridges cultural and linguistic barriers, promoting inclusivity and collaboration, thus preparing students to thrive in a diverse, interconnected world. That is all from me. Thank you.